Hello and welcome back. In this module, we'll discuss how to create a schematic diagram, and let me take you to the circuit. This is the circuit that we are looking to create. In the previous module, we have created libraries for these components, all the components involved here in this schematic. So we can use those components in Altium Designer to create a circuit, a regulator circuit that gives here adjustable output, 5 volt fixed DC output, and then a 12-volt output. So let's get started. So if you have created your schematic library, it should be added here, and you can go to the components palette, and here you can see that you have two libraries. One is the PCB library and the other is schematic library. You can switch between these libraries here. Please notice that if you have selected your PCB library, you cannot drag and drop your component here. That's because this IC symbol represents that this is a footprint, and it belongs to the PCB library, not the schematic library. To create your schematic, you need to add components from your schematic library. So here you can choose your schematic library. If your schematic file is closed, for instance, you have closed, you can just double click here and you can open it again. Okay, and if you have moved it to the left or right, you can just press Control page down, and then you can fit to the screen. And this is your working area where you can drag and drop your components. So let's get started with the schematic library at hand. Let me first drag and drop LM350. So for LM350, I have created the schematic symbol here. I'll just drag, and then as I leave the left mouse key, it will be added to the schematic. Now the second thing that I want to add here is the LM 7805 and LM 7812, because two regulator ICs are involved here. Since they both have the same pin numbers and the same footprint, so I can add two of them, one for 5 volt regulator and the other for 12 volt regulator. Alright, so now we can add the other components. For instance, let's say we have input capacitor and an output capacitor. So I'll just add input capacitor from polar. I'll add a polar capacitor at the input here, and I can just copy and paste if I want, instead of dragging the same components again and again. I can also copy, and once I have copied, I can paste many times, as many times as I want. So I have pasted the input capacitor. Similarly, I can add to the output, and another one here. I would also like to add the non-polar capacitor. That is normally good to reduce the parasitic resistance. So again, I'll copy, and I'll try to move it to the right, so it should be close to this IC. This I can select two by pressing the shift key. I can select more than one, and then I can just drag it to the location wherever we want. Similarly, I can, if I want to continue that patch instead of using these, the good thing is I can just delete them by selecting and pressing delete key, and then I can select those four, Control C and Control V, and I'll get it and get them here. Okay, similarly I can also replace this guy and this guy with. Okay, please notice that here's the thing, that if I click somewhere like on the comment, you see that the box around this component is they are unfilled squares. If I click on the middle, the box is now the corner of this box are filled square, and they are green. Okay, so this shows you the difference, that the component is selected or only the comment is selected. This time only the comment is selected and I can drag it anywhere. So that's the difference. So if you want to drag this component, make sure that your comment is not selected but the component. So for that you need to ensure that there's a green box around the component. This means that now you can drag it. So I'll also copy and paste. Now you can see that the key component is in green and the other becomes blue. The box around that component becomes blue. That means that all of them are selected. So we have added our components. The other components that we need are we need a variable resistor and a fixed resistor in case of the adjustable regulator. So I'll just add a variable resistor here, and then I'll add a fixed resistor here on top. So I'll just move them to the right like this. Okay. So this looks fine, and one more capacitor I might need here between the between the adjust pin and the ground. So this is something I need. So now we have dragged almost every component. We can two things we need to do. One is to connect them with lines, and the other thing is we need to change the designator. For example, these capacitors got the same designator, and since we'll export this file to create the PCB file, and in order to have PCB file, there we need to have a unique designator for each component. So for that, we'll change the designator of each component one by one. Alright, so let's start with this guy. So I'll just click and then I'll go to the properties. In the properties here I have C1, so I'll just name it like so that it becomes easy for me to spot out on the PCB that where exactly this C belongs. So I'll just add another A for adjustable, so that I can recognize it later. Maybe it will the designator will seems quite long, but it's helpful. So let me use CA1. The designator of the first capacitor is CA1, and in the comment section I'll use the value. Right, that's important, that we need to know what value CA1 should be. I'm going to drag it to the left so it's more clear. So now I can change, just click it, and in the comment I'm going to use, let's say, 10 microfarad. Similarly, for the other capacitor I'm going to use CA2, and I'm going to use the value of 1 microfarad. Okay, so we'll just go this way. Similarly, CA3, and again I'm going to use a 1 microfarad capacitor. I'm going to use, let's say, CA4 and a 10 microfarad of capacitor. So you can see that the CA will guide me that the reason behind that CA is it will guide me that I'm referring to these capacitors which are closer to the adjustable regulator. What about the adjustable regulator? Let me label it like U adjustable regulator IC. So that's the designator for this guy, and the comment is LM350. Okay, so I can make it short like UADJ. Alright, so next I can move it a little bit to the right to make it more visible, more clearly visible. Okay, and try to follow the convention. Like here I'm using the convention designator on top, value at the bottom. Designator on the top, value at the bottom. Use this. Use consistently this pattern so you may not get confused. Alright, so next is the resistor. So for the resistor, I'm going to use the value of, I'm going to designate it RA1. That's fine. And for the value, I'm going to use 120. Alright, maybe 120R to make it clear that this is the value of resistance. Alright, so alright, here I'm going to use, for instance, CA5, and I'm going to use a value of 1 microfarad, and that's it. Here I'm going to use VR1. Okay, that's variable resistor 1, and it should be a 10k variable resistor. So I'm going with the 10k. I'll move it to the left of this like this. So I'm done with almost done with the first IC, and let me complete this before going ahead. So here are the guys. Here's what I'm going to do is to connect these lines. Okay, so for the input I'm going to move it to the left and just connect these over here, move it to the right. Okay, can you see that the static, the cross here, can you see it's gray in color, but when it touches this end, it means that you can start a line from here. So I'll just drag it here, then here, and now you can see that it turned one more time, it turned blue. So now you can end your line here. So once done, you can connect it here. It will turn into that dot, means that the connection has been made, and then we can connect these points like this. Right, that's quite straightforward. The final thing I need to check, yeah, connect the terminal, the variable terminal like this. Also, I'm going to connect this here. Okay, so we are done first part of the circuit. Okay, I'm going to select this and I'm going to move it up a little bit. Okay, so now here's the thing, that this board is going to be my input. On the left I'm going to apply the input, and on the right I'm going to get my output. So for that I'm going to choose input from here, and I'll just put it here, and I'll use a ground from here. So I'll use them as the input terminals for now. I can connect the input here, and the ground I can connect it here. Okay, so this is my input. I have applied, let's say I need to be specific. I'll just double click and change the properties to 24 volt. So I want to apply a 24 volt input, and it will give me a 12 volt output. I'll just match these lines. So my output is going to be 12 volt. So no need for the ground. I have already connected the ground. I'll just label this in as again, since this is a different voltage, I'll just label this guy as 12 volt plus 12 volt. Okay. So now wherever I want to use this 12 volt, I'll just use the net. I mean the net for this guy is plus 12 volt. Okay, this is the net name. So I can use elsewhere. For example, if I drag somewhere here and I just label it plus 12 volt, then it means that these two are actually connected with each other. For that you can use your alt key, hold your alt key, and click on that particular net, and you'll see that where else in the circuit that net is used, or where actually is that this part will be connected. So it is also connected to this guy. To clear your selection, press Shift C and your selection will clear. Again, press Alt key on your keyboard and then press on that net, and you can see that the only part in the circuit where this net is used is here, and it's also connected here. And if you again, in addition to using Shift C, you can click somewhere in the schematic workspace, and your selection is clear. So this is the first thing we have done. We have created this schematic for adjustable regulator. So whenever, again, let me complete this part, wherever we want to use the 12 volt, we'll just use these two guys, and that's what completes our 12 volt supply. So that's the output from this supply. These two lines are the output from this adjustable regulator. So now we'll quickly complete this part and the other one. Let me just name it U5. That will give me the idea that this is actually even I can use the V. This is a 5 volt regulator, and if this is a 5 volt regulator, then it means I can write it. It's in the comment I can write it LM7805, and similarly I can label the other guys. These are C51, then it will represent that I'm now dealing with the 5 volt regulator. This is much handy. And similarly I'm gonna use the value again, let's say 10 microfarad, and then I'm going to use C52, and it gives again 1 microfarad. For instance, I'm going to use this value. So much better. So I can also designate this guy as C53, and the value is 1 microfarad. I can use a value of, let's say, 10 microfarad for C54, 10 microfarad, and then I'm going to use the value. Okay, and then here once again I'm going to use these two nets. I'll just select them, copy, and then I'll paste, and here I'm going to just drag it a little bit upward. Okay, now I can connect them. From here I can drag a line here, for here, from here I will just drag a line here, and just you need to connect them like this. I'll just draw a line for the ground like this, and right click to end that line, drag and connect, drag and connect, just click here and then here, and then those connects your line. So whenever you are done, just right click and the tool is no longer here. Here you are not in that tool mode, and now I can use again a VCC for, let's say, let me now name it plus 5 volt. So this time it's a plus 5 volt. So I can, my second terminal is going to be, output terminal is going to be a 12 volt, sorry, a 5 volt, and this was sorry, I made a mistake. This is the adjustable output. So plus variable, so I'll just type in VAR, and I'll just also label it plus VAR, because that's not a variable regulator. That's not a fixed regulator of 12 volt, and the fixed regulator of 12 volt is here. So I'll just use this guy plus 12V, and things will get easy for me if I even use these capacitors. Okay, so you can see that these are not selected properly. Now I can copy and paste. I'll use them. Okay, so the values are now already assigned, but I need to change the designator. So I'm going to designate C. Okay, so C12 is not going to, it's going to be quite long. So let me use T for 12, CT1, instead of using the 12 numeric. So CT2. Okay, so another convention we have started. CT3, and then we have this CT4. Okay, I'll just again select them and move them a little bit downward. Again, my input is going to be the 24 volts, so I'm going to put it like this. Again, I'm going to select the place wire tool. I'll just drag, and this is it. I don't want any further line. I'll just right click, and now I'll drag a line for the, draw a line for the ground. I'll just click here even further, and then right click to discontinue here. I'll discontinue. Now I'm going to connect these terminals here and here and here. Simply I'm going to connect these also. So now this is our 12-volt output. I'm going to use the designator. The name for the net is plus 12-volt. I'll just copy and paste it here, and similarly the ground is already connected, so I don't need. Okay, so that this completes our very basic circuit of I'll just say very basic circuit of variable and fixed regulator that we discussed from the very first tutorial. Here I want to show you something that, again, if you press your Alt key on your keyboard and click any of the nets, so I'm going to use plus 24 net, you see that all of these guys are connected. Okay, these you can see that these are the three places where the 24 net is connected. All right, so similarly, let me check the ground. So you can check your ground and you can see that where exactly is the ground terminal connected. So you can check your circuit quickly whether anything is missing or not. Okay, whether the connection is proper or not. For instance, if you might face some condition, let's say you might not be sure that whether your connection is proper or not. So right, let me see this guy. You have some options to explore here. For example, you can use M key on your keyboard and you have the options drag. So if you use this option, you can use your net, you can take it to anywhere, but it will stay still connected. Okay, so this is a very nice tool to make sure that your connection is still there, and then you can arrange your circuit much quicker like this. Right, similarly you can align your components. For example, you can make it much cleaner, and by selecting, let's say, all those three and then using this align horizontal centers. So I select the other guys. Okay, so now they are aligned, but you can see that this one is no longer connected, and maybe I instead of the net, I just select so I just selected this net, so it didn't carry that Y. So I can now move it down somewhere to connect like this. Alright, so this is how you complete your circuit. And two more things we need to address, but probably I'll keep that for the next module, is that where the input is going to what kind of input terminal will have. Similarly, the output terminal, the input and output terminals, these are the two things that we need to consider. For instance, this is for the schema. From schematic point of view, this is okay. It looks okay, but if we think from a PCB point of view, we need to have a connector, an input connector and at least 3 output connectors, each connector for variable, one for variable, one for 5, one for 12 volt. Similarly, we can have a single 24 volt connector where we can input all 24 volt. So for these, we need to add an additional uh, an additional connector, maybe a barrel jack at the input side and a block connector at the output side. So before converting this into your PCB file, you need to make sure that all your components are on the board. Even if you convert it, if you export it to your PCB file and you realize there that you don't have any terminals, you don't have any connectors for the inputs and outputs, you can fix that later. You can come back to the circuit and add these schematic symbols here with the footprints, and then when you export, you'll get the footprint in your PCB file. So I'll just save it for now, and we'll get into the details of exporting into a PCB file in the next tutorial. Thank you.